Hey everyone, welcome to the Basics of Breaking BLE Part 2, Doing More with Less. My name is Freqy. I'm a security consultant with IO Active. I was class of 2020, finished up a BS in Info Assurance and Cybersecurity. I'm currently studying a Master's of Cybersecurity and Leadership. If you would like to contact me after this presentation, you can get a hold of me on Twitter at FreakyZen. So when I was trying to come up with kind of the topic of this talk, I wanted to focus on something that I've kind of been trying to do myself in my work, which is doing more effective work with less tools, or I would say less expensive tools, things that are at hand, things that I don't have to grab specialized work orders for or request orders for. So I kind of came up with these three kind of general thoughts around this, which are run lean, so use cheaper equipment, run fast, utilize the tools that we have at hand, the things that are built into the operating systems that we already use, and run more. So always clone active Bluetooth. If you're not practicing these things, then it's going to be really difficult to perform effectively when it comes time to actually perform a Bluetooth pen test or assessment. So just constantly practicing these skills and just looking for things out in the wild. So if you're saying this is part 2, I didn't see the first one. Well, the first one was hosted by the RF Village last year during DEF CON Safe Mode. There's a link there, or a QR code if you would like to view that. It's a little more generalized, basic information, kind of introduction to Bluetooth. I am going to go over some basics in this video, but not quite in depth, not as in depth as I did in the previous video, for obvious reasons. So yeah, hopefully you can follow along with this video, or you have time to check out the other video and then come back and watch this one, and you'll hopefully have a little more context if you're not already familiar with Bluetooth. So just a couple of basic terms. I'm going to kind of breeze through these. So you have two main device types within a Bluetooth connection, and generally that's central and peripheral. So your central devices are going to be things like your phone, or your laptop, something like that, something where there's generally user input that's going to be involved. And your peripherals are things like sensors or fitness trackers that don't have any kind of user input, things that generally don't think for themselves, I guess. Those are peripherals within the devices, or within the connections. This has a big part in how devices interact within the Bluetooth profiles that they operate on. So that can be very important when analyzing Bluetooth connections. So just some more basic information about Bluetooth connections. We have 3 main advertising channels, 37, 38, and 39. There are 36 channels overall, separated by 2 megahertz. And then there are 2 processes, pairing and bonding. Pairing is where we pass temporary keys in order to upgrade into a bonding session. So bonding is where you exchange long-term keys and you upgrade the security of the connection. Okay, primarily what I do on Bluetooth assessments is look for poor implementations of GATT security, or things that allow me to interact with GATT services on a device. So you can think of GATT as sort of a catalog of services, and basically the processes in which you interact with them. So characteristics are kind of a sub-level of services within GATT, and characteristics will have things like read and write properties or descriptors or values. They'll carry some information from the central device to a peripheral or vice versa. They're kind of the backbone for the Bluetooth communications. So as I was saying before, generally what I look for on assessments are poor implementations of GATT security. And this would include being able to write commands, simple commands to GATT services that are open or have little authentication. And you'd get all kinds of interesting results from that. In previous talks, I've mentioned devices that were able to heat up to the point where they would burn someone. Over-the-air firmware updates, as you'll see later in this talk, something a little more, a little bit more impactful than that. Of course, I guess getting burned could be impactful. So we're going to move out of kind of the introductory stuff. Like I said, if you want to check out the first video for a little more context, I would urge you to do that. But we're going to go into the tools of the trade. And this is kind of where we get into the do more with less. Elisa's has a very expensive box, and they have actually a series of devices, and they're all various SDR, FPGA type of devices used for broad spectrum scanning of Bluetooth or wireless or any kind of mixture of wireless protocols. The problem is these devices are extremely expensive. Some of them can cost upwards of $30,000. So these are really cost prohibitive to independent researchers unless you just have really deep pockets. And even a lot of small companies really can't afford some of this equipment. Like, you sink 5 figures on something that just does Bluetooth or a mixture of wireless things. That's a big investment. So you probably need to be turning out a lot of Bluetooth work. For this reason, it's pretty rare to see these in engagements. I have used these before where we have rented them from equipment suppliers, but even then, 2-week engagement, we're talking $3,000–4,000 sometimes to rent one of these devices. And they do an amazing job. You aren't wasting your money per se. What you're really paying for is the value of the software that they've developed to operate on these devices. And that software allows you to peer into Bluetooth connections or wireless connections, but Bluetooth connections in our context, in a way that open source or consumer level products really can't. And they give you a deep analysis of what is actually happening over the air. And for that reason, you can justify some of the cost to, access the software and then their specially built devices. The other thing I would say is that these aren't really intended for beginners. I have used these systems, as I said. They weren't exactly complicated to set up, but they weren't exactly user-friendly either. Even though they're closed source software and you pay a lot of money for it, there can still be bugs. They might not work on your operating system, your specific flavor of your operating system. So there are all types of things that can happen with these. So where do we get the less when we're doing more? Well, enter the NRF Sniffer for Bluetooth LE. Nordic is a wonderful company. I absolutely adore everything that they do. And I have to excuse some of the formatting on this slide. But basically, they've come up with a plugin for Wireshark that allows you to use one of their Nordic development kits or one of their dongles, like the NRF 52840 that's pictured over here, in a way that is kind of a poke in the eye to these really expensive Bluetooth sniffing systems. Yeah, so you can follow the link there, and that will kind of give you some details, more details on the system itself. But we're going to get a little deeper into these because this is an interesting system. You can see where I have it marked out there, struck through. And in previous presentations, I've mentioned this system, and all of my experiences up until recently had been that it was very hard to get working. was not compatible with things and seemed like it was very much in early stages of development. But that's not to say that some people didn't get it working and had great results from it. There has since been a lot of work that has been put into it, and it is actually pretty nice to use now. There are still a couple of little bugs that I'll show you some workarounds for that I've found. But apart from those bugs, it works pretty good. So I wanted to highlight it in this talk. So what is the Nordic Sniffer? As I said, it works with any of their development kit, or well, most of their development kits and their dongles, like the NRF 52840, which is the one that I recommend you use. And like I said, it's a little buggy, so here are kind of, my workaround for that. After you download the firmware, they have good instructions on how to get it set up. Just follow those exactly, and you should be able to follow the rest of these instructions. So what I've done, and I will actually go through a live demo here in a second of this as well, but just to go through the steps. I'm going to start Wireshark as root with the sniffer plugged into my USB port. So I have an NRF 52840 that has been flashed with the sniffer for BLE firmware. I'm going to start Wireshark as root with that plugged into the USB port. I'm going to double click on the interface from the main window, and this is generally, in my experience, creates an error every time. If it doesn't create an error, you just won't see any packet streaming, which is also concerning. It doesn't seem like it's working. Go ahead and press OK on those and quit out of that, and then we will remove, reinsert. LED shouldn't be blinking, and then we'll click on the interface again. So let me switch over to my laptop. You can see this extra tab here, or this extra view that pops up. You can access this from the interface toolbar that's available under the view menu. So we want to select our NRF sniffer. I went ahead and refreshed the interfaces to bring it up, and then I could select it here from the toolbar view. And you can see that we have a few options here. We have the passkey, OBB, and also the advertising channels that we want to hop across. So what I'm going to do is double click on the sniffer from here, and this should generate an error. Okay, so we've got our error here. We're going to click back, spits us back to the main window. I'm going to pull the sniffer out of the USB port and plug it back in. The LED should not be blinking now. And I'm going to double click on the interface again. And we don't have any packets streaming, but we are picking up stations here. So it might actually take a couple of times of doing this. I have ran into issues where this happens before. Okay, so we're now seeing our packets stream through. These are coming through the BLE sniffer. So these are basically advertising packets that are going through, connection requests, publicly broadcastable things that are viewable on the BLE spectrum. So we have a device, and I think maybe I should skip to the next slide. Yeah, so I'm going to leave this running. I'm going to skip to the next slide. And talk about another portion of doing more with less. We'll come back to the sniffer in a second. So in kind of using our built-in tools, if you're on a Linux system, you have BlueZ, which is both good and bad. It has some great tools built into it. Blueman, HCI tools, HCI config, which enable you to do some pretty powerful stuff from the command line, like this bash one-liner, this terrible example of a bash one-liner. It's just kind of an example of what you could do with HCI tool, and some of the intricacies that you might need to do. In its current form, BlueZ is pretty stable. I would put an asterisk mark there. And it has quite a bit of functionality in regards to, what the tools can actually do with peripherals or central devices, or, just how you can set up connections with it. The asterisk that I would put there in its stability would be that it still has an active bug in it that will basically seg fault your system with certain types of Bluetooth low energy connections. I'm working on something that will allow for a remote attacker to exploit this, but I don't think it's anywhere near ready, and I didn't want to kind of show partial code. But yeah, just know that I think that's something that is possible, and it is still a bug that is happening in 5.5, the newest version of BlueZ that is out currently. I think 5.56 is being tested, and there might even be development work on 5.57. I'm not really sure. I don't keep up with it a ton, but yeah, it's still out there. So if any of you follow me on Twitter, you may have heard me talking about developing a new tool, and that new tool was called Protomolecule. This is taken from one of my favorite science fictions series to come out, The Expanse, which is just absolutely amazing. I would highly recommend it, but that's where I stole this from. So what's the situation with Protomolecule? And some of you are probably asking, what is it? So Protomolecule is a BLE exploration tool in that it does logging and continuous sniffing, but it tries to enumerate attributes of BLE devices that it sees. It will also attempt connections to do further attribution of GAT services or permissions. And it also has a functioning tracking and triangulation, with an asterisk there, capabilities. It will triangulate, but you would have to do the calculations manually. So you would need independent remote stations. That's something that will be coming in later iterations. We'll actually have intercommunication between the sensors or the nodes, so that they can actually pass this information back, and then you would be able to get triangulation information back in real time. So yeah, and also coming eventually, we're going to add teeth to it. So a known exploit database, so values that will have certain functionality on certain GAT services on certain devices. Creating a known catalog of this, and creating the method for utilizing those exploits will be coming. There will be also planned as an auto exploit mode, where it just tries to own everything it sees. Obviously, we're trying to build in cross-platform support. That was a lot of the initial motivation for building the tool, was having something that would operate cross-platform in a way that BLE testers were kind of needing a tool to do. They need something to identify, a target, make enumerations of its services, and then, potentially lodge attacks towards it from the same tool, all while it's taking logs and keeping track of everything that's going on. Eventually, we would like to have some kind of formalized report system where it actually outputs reports, but this is very long ways down the line, and work has been pretty slow on it. So yeah, that's Protomolecule. So yeah, where is it? Well, we've been working on it for a few months now, and I have to say that I've gotten an intimate working knowledge of BlueZ working on this project, in kind of all its quirkiness. We've written it in Go, so we've used a number of different libraries, TinyGo and Go BLE, and they are just kind of wrappers over wrappers over wrappers for what is Bluetooth, or what is BlueZ. And once you start digging into it, you see why these wrappers exist and why they're being utilized so heavily within Go-based Bluetooth code. Or any code, I would assume, but Go is what I have experience with in working with BlueZ. It's that BlueZ is very difficult to work with. It's not not straightforward. It's very esoteric. Maybe some people find it simple, but I have yet to find a mental approach to it that makes consistent sense. There are also a number of bugs, which makes it very difficult to actually develop software on. The segfault error of which became a huge concern as we were all sitting around trying to figure out why our systems were locking up when we tried to connect and scan Bluetooth devices. So yeah, that's kind of a interesting thing I've learned while trying to develop a Bluetooth tool. Okay, so here's to running more and practicing, our skills on a consistent basis. So I like to think of this as habitual sniffer ops. If I am standing somewhere in public for more than about 30 seconds, I'm probably going to pull my phone out, but the likelihood that I'm looking at social media or text messages or emails are fairly low. Generally, what I'm doing is scanning Bluetooth around me. I'm using NRF Connect to scan my immediate surroundings, and I'm looking for devices. Generally, I'm ignoring people's cell phones. They're not very interesting. For the most part, they're fairly locked down, just from basic GAT connections. What I'm looking for are interesting things. Door locks, sprinkler systems, security systems, cashier systems, receipt printing, thermostats, measuring tools, street lights, all sorts of things that I've seen. But it's amazing what is using Bluetooth around us, and it seems like some of these devices are rather primed to being attacked over Bluetooth. One thing I would add about the habitual sniffer ops is, persistence wins. Sometimes when we're trying to connect to these devices, they will reject our connections. I will show you a couple of things that I've learned here in a few slides that have helped me kind of force connections through to devices that are a little bit fussy. But just being persistent with that will generally let you at least get a connection long enough to clone the device's services or potentially read data from its GAT services. The other thing I would say is observe, refine, repeat. This is a process. You want to practice this, coming into an area, scanning what's around you, picking out the interesting things, pulling its GAT down, looking through the values, seeing what you can see, what information can you find out about the device. Do you get a software version? Do you get a manufacturer? Do you get some kind of, identifiable information that you can take from that device and then do research? Generally, you can do, a Google search of, some just names of Bluetooth devices that are that are broadcast, and it will bring up, user manuals and all sorts of things, and then you can learn about, like, what is this? Okay, there's this signal that's going off. Oh, it's some kind of thermostat, or it's some kind of electronic calipers I saw one time. Just the strangest things with Bluetooth on it. And as you do research, you start seeing that there are a lot of systems that have, kind of vulnerable pathways into them over Bluetooth. So yeah, that's what I would recommend, just as kind of a strategy, kind of to approach habitual sniffing operations. Okay, so again, if you were following my Twitter, you might have seen that while I was preparing the demos for this talk, that I found a couple of issues with the with the device that I chose to do a demo on. So this is Jordan, the MP686 BLE transceiver, for lack of a better term. They don't have much to actually identify what it is. It's just kind of that nomenclature that's on it. It is a Chinese device. It's really cheap, available on Amazon. But it's an aftermarket device that allows you to connect your phone Bluetooth to your car. So you can have things like remote unlock and lock with your phone app, trunk release, and also remote start. And I thought, it's funny, on the front of the manual, there's actually this little like subtitle that says Smart Key with PKE Car Anti-Theft. And I thought that was hilarious after I started poking around in this, because it is very much not an anti-theft device. I will walk you through kind of a live scan of it, and I will show you what I found. But just as initial overview of kind of the preliminary findings, or the initial findings, because I'm still researching this device now that I've kind of broken it out and seen, like, okay, there are issues, now I want to get deeper into it. Just initially, the default pin set to 000000. I didn't have to dig very far to find this information. It was right on the outside of the box. It's in the documentation, and in fact, the documentation actually says that you need to change this, and that any phone can connect to this device using this pin. Great, that's wonderful advice. It'd be better if they didn't do that. But in reality, the device doesn't do that. It actually doesn't use a pin, from what I've seen, at least not viewable to the user. So I would think that it's actually using just works, or it's using a hidden pin with a simple user button press to confirm pairing, because that's all you do. But also, contrary to the instructions, there isn't a way to change that. So you don't really have the ability to harden this connection, because it allows multiple devices to bond to it. So your pairing requests, and I noticed from while I was using two devices, if I sent multiple pairing requests over and over and over again, I would actually DOS my legitimate connection into it dropping out, and my attacking device, I could then create a paired session and then bond to the access control system, and then I could send authenticated commands to it. So obviously this is an issue. That means that the connection isn't protected by a one-time bonded device. I have seen some devices that only allow for one device to bond to it at a time. After that, it actually has to go through like a physical reset process where you have to erase the bonding information within the device. This doesn't have that. And not only does it not have that, but it doesn't limit the number of devices that will bond to it. So that means that, any number of people could then create a bonding session with your car access device and create, you know, this exchange of trusted keys. Um, so obviously an issue, unless you want everybody to be able to borrow your car, in which case, you know, more power to you. I salute you. That's wonderful. Um, but for people who would like to keep their cars, um, this is kind of highlighted in the fact that they expose some very risky GAT services. Um, One of them looks to be over-the-air firmware updates, which I don't think I need to explain to most of you why that's dangerous. And also the lock and unlock and start functions of a vehicle. Again, I don't think I need to explain why that's a dangerous thing to be able to have anyone connect to, create an authenticated session, and then send these commands to your vehicle. I will say now that I haven't got to the point where I've reversed the commands. That'll be kind of the next step that I take. If you would like to know what that process looks like, that is also in the first video. So let me kind of do a live demonstration here of what we're looking at. Okay, so we're still streaming packets from Wireshark here, and you can see that I have my phone brought up on the screen as well. So what I'm going to do is actually scan for my target device here. Here it is right here. So this is the vehicle access system. Now in the wild, when I'm talking about like cloning every device that you see, there is a device, or there's a button here on NRF Connect that will allow you to clone a device's advertising information. So basically all this information you see here, it will allow you to clone that, and it will go into your advertising tab here, and you can edit some of the information, but then you can turn it on to actually broadcast. So you can see the device that I've captured is here. You can also see the huge number of devices that I have captured previously. As mentioned, I am always scanning, I'm always cloning, I'm always looking for interesting things. Another thing that I will say is that NRF Connect is capable of spinning up 11 or 12 simultaneous advertising sessions. So you can actually spin up a lot of instances, and this can go a long ways in confusing central devices and which peripheral they're actually connecting to, which can be another kind of attack strategy when you are looking to test BLE devices. Okay, so so I've cloned it. We're not really worried about that right now. What we want to do is connect to it. And here, suppose I should have deleted the bonding information just so we do it. Okay, so we have my device here that we're going to connect to. Open here. You can see that we're disconnected, we're not bonded. So I'm gonna hit connect, and you can see the stream that came through on the other side. So we actually saw information being passed over the NRF sniffer here through Wireshark. Okay, so I'm going to attempt to create a bonded session, and we've passed that bonded information now. Oh no, we've disconnected. This is what I meant by persistence as well. Sometimes this will take a number of attempts to actually get a bonded session to go through. Sometimes it will take a number of attempts to get a pairing session to go through. In which case, I like to go through and set the initial preferred PHY, and I like to check all of these. That just, in my eyes, in my opinion, enables your device to kind of be, broadly accessible. So we're going to start scanning with our new, or we're going to start a pairing session with our new settings here. And it should go through a little easier. Okay, so we've created a bonding session here, and we're going to go ahead and hit pair on it. We've now bonded, so we've exchanged long-term keys with it, even though we haven't been able to establish a direct connection. Okay, now we're connected. So what we can do is go in here, we can read characteristics of the device. We can see the device name, PM913I. Okay, so device information. How about device services? So we can see things. Oh, okay. Auto connect is also a great option because sometimes these connections are very finicky. We can go in and see that we have write and write no response permissions here on this SPPWO and this SPPRO. I don't know what these are yet. I will still have to find out what they do. We also have the CMD-RW. Again, I don't know what these do yet, but we do have write permissions and read permissions on these characteristics. So you can see how this is an issue. You can see that there was no further control over how the device actually connected to our phone, and that anyone could do this if they were in vicinity. They could push your phone connection off of this device and then attempt a connection or a pairing and a bonding session with the device, with your vehicle, essentially. So you can see the packets streaming through here in Wireshark. We can actually go in and isolate some of the devices here. There we go. So now we can isolate our target device here, and we can actually watch for things that are happening with that device only. So let's see if we can capture a connecting session. So you kind of get a sense of how powerful the tools are that we have on hand. The NRF 52840 is like $10, minus shipping. NRF Connect is free on your phone. If you have an Android device, it does work on iOS, but in the past I have seen a lot of people have trouble with the iOS version. So I always recommend that people use an Android device if they're going to be doing any kind of serious Bluetooth testing, unless the platform that you are testing, like a mobile application or something, is on iOS. There is another process for actually capturing Bluetooth packets within a debugging tool on iOS, but I'm not familiar with it. It's something I'm still learning, so I'm sure that will be in future talks. So let's switch back to slides here. Yeah, and this is kind of a standard slide that I put in a lot of my talks, but if you would like more study on wireless or Bluetooth in general, I always recommend Joshua Wright and Jessica. Jessica is absolutely amazing. The research that they are doing is just absolutely mind-boggling and completely industry driving. So I would highly recommend that you follow them. If not on Twitter, at least follow their work. With internal Blue and all of the really neat reverse engineering things that they do. YouTube is a great resource as well. There's lots of videos on Bluetooth and just how to implement Bluetooth devices, along with my videos that I've created. And also there are a number of learning devices: Adafruit, Bluefruit LE, the Thingy 52, also from Nordic, the ESP32, and then kind of the star of the show, the NRF 52840 dongle. These are all things that I highly recommend if you are looking to get into Bluetooth, or if you're looking to get into testing Bluetooth. These are things that I would recommend that you pick up and check out. So thank you for spending this time with me. Hopefully you're all staying safe, enjoying your DEF CON, whether that's in person or virtually. Hopefully next year we can all kind of gather in the same place and we don't have to worry about COVID. And yeah, hopefully it'll be better times for everyone. So thank you again, and feel free to reach out to me on Twitter, or if you see me walking around DEF CON, I'll be down there for a day. So feel free to come up and ask me about Bluetooth if you want. So, all right, thanks, Elle. Bye.